Am I audible? Is it fine?
Yes, sir. Yes, sir. Audible, sir.
Okay, that's fine. Let me know when I can start. Okay.
Yeah. Thank you, sir. So, shall we start, sir?
Yeah, sure. I'm ready. Yeah.
Yeah. Thank you, sir. Thank you.
Yeah, you want me to start?
Very good afternoon, everyone. It's my pleasure to welcome our today's resource person, Mr. Arun Kumar, Technical Manager, Nokia Network Chennai, and all the participants for a Day 2 Session 3 ATAL AICT sponsored FTP on Internet of Things in Smart Cities, organizing by Department of Electronics and Communication Engineering of Tamil Nadu College of Engineering and Technology. Welcome you all. The presence of a true spiritual teacher, reading inspiring words and letting in inspiring thoughts tend to make the mind peaceful. Before going to session, let me see the short intro about our resource person, Mr. Arun Kumar. He completed his bachelor's in electrical engineering from Satyabana University, Chennai. He is a Nokia certified professional for the radio experiences and also working with the 5G radio since 2017. He is a lead 5G launch projects globally and also skilled in a root cause analysis for a 5G radio related problems. His job profiles includes uses advanced analytical skill and troubleshooting methods such as system level tracing, debug protocol, flow analysis, and etc. to provide a work and around and solve complex problems in a 5G radio network. He technical activities such as a software upgrade, future testing, triple technical support, end-to-end performance improvement, and so on. His skilled topics includes a 5G NSA and SA call setup, telecom protocol analysis, 5G BTS, carrier aggregation, and packet scheduling. So without wasting time, now I like to hand over the session to our resource person, Mr. Arun Kumar. Please, sir.
Thanks for the introduction. Thank you. Let me take off from now. Let me share my screen. Please interrupt me, my voice quality, or if my screen is not visible, right?
Yes,
Okay.
sir. Your screen is visible and everything perfect, sir.
Okay. Thank you. And yeah, as he mentioned, I'm working for Nokia Networks for last 12 years, and for last 5 to 6 years, I'm working for 5G, right? And I think so. Basically, I'm supporting North American customers, right, where you have 5G deployed. Earlier, we have South Korea, Japan, Europe, and North America, and all the top network operators operating 5G globally, right? India is yet to start the race for 5G, right? Maybe 2022 they will do that, but other operators worldwide, they already had so much ahead of us, at least 3 to 4 years ahead of us. So basically, right, so I'm trying to bring that experience, right, what I had in my professional career, bring to the table, right? I was asked to present slide or present session on 5G in smart city, right? I think most of them, everyone knows what is 5G, right? Basically 5G and how we are going to utilize 5G in smart city. That's what we are going to do. That's what we are going to learn. I will try to give as much as information possible, right? What we have in the table. So it's not going to be much of a technical. Yes, there will be some technical aspects, but since it's an application session, right? Smart city is an application, right? It's a business. So it's going to be, I am going to touch base on all key concepts and give you some live examples, right? How it looks like globally. Because in India, we don't see the 5G as of now. It's in trial phase, but it's already implemented successfully in across global on different verticals. So I'm going to present some, right, whatever. With that, let me go to the first slide. So this is the expected outcome, right? So what you expect. So I always set expectation before my session. So it's easier to understand the expectations, right? So goes. So before going to smart city concept, I like to touch base on what is 5G, what are the key aspects, and how it different from existing technology. We already have 4G, we already have Wi-Fi. Why we need 5G, right? It should be necessary to develop something. So what are the disadvantages 4G has? What is the new advantages 5G is bringing in? That's what I'm going to give you some touch base on 5G basics. And that one I won't cover much on that because the most we need to cover on smart city. And then once 5G basics is done, we'll cover the smart city. What does it mean exactly smart city, right? What are the components involved in that? And once we understand the smart city, then how 5G can help smart city? What benefits it is bringing in, right? How operators can make utilize 5G and bring it into a product, right? Smart city is a product, and how that product can be utilized by using the 5G. Okay, and finally the use cases with success story. So basically, smart city is a larger picture. It's infrastructure, and inside there will be a lot of other stuff: transport, healthcare, power grid, video surveillance, analytics, immersive experience, smart building. We have few more cases also, but I just put top 6 cases here, and I'm going to give you how 5G will help here, and what are the success story behind it. How in globally where it is installed, where it is developed, and you can get some idea. Okay, this is smart city, and these are the components involved. And when it come to our country or our city, then you will understand. Okay, well, this is what is going to happen, right? That's a key thing. Okay, that's fine. So moving on to the first topic, understand 5G basics. 5G it's a new radio. In a technological term, 5G is called as a new radio, and LTE is called as 4G is called as LTE, right? LTE, long term evolution. Similarly, 5G is called as new radio. It is nothing. It's like a standard. It's a set of protocols, set of standard developed by 3GPP. 3GPP is the board which controls the telecom standard. It's an organization for telecom standard, right? And it's developed 5G NR, and starting from release 15, there are a lot of releases, release 8, 9, 10, where it covers the LTE, and the 5G starts from release 15. Okay, so basically what you have to learn from this slide is, okay, 5G is a new radio. It's developed by a 3GPP standard organization. It's a global, right? Every operator in the world needs to follow this set of rules. For example, it will help, it will give, okay, this is a radio network and these are the protocol stack you have to use. This is the messaging format you have to use. So even the messaging format will be designed by 3GPP, right? Every operator in the, for example, operator, I mean the Vodafone here, Jio, or in outside the global, there's a T-Mobile, AT&T, Verizon. So a lot of operator, everyone should follow the same standards. That's where we are. So 5G new radio release 15 is a start. Okay, we have currently we have release 16 and 17 happening, but the start for 5G is release 15. So what primary difference here is radio. So there are a lot of components, right? In telecom, you will have a radio where transceiver, right? Transmitter and receiver will be placed, which will receive and transmit data from your device, the mobile. And behind it, there are other components, switches, switching, PSTN. There are a lot of other components, right? Core, they call it as core. You packet switching, circuit switching. There are a lot of other stuff, but majority of the changes will always happen in radio. Okay, other stuff for generic switches, right? There is not much changes. So most of the thing is changes in air interface. We call it as a radio or air interface, right? So what are the changes we are going to do, and how it improves, or how it improves our smart city or helps smart city? That's what we are leading into. With that, I'm moving to the next slide. Okay, why we need 5G? So we already have 4G. Why we need 5G? Because citizens and ourselves as an end user, we demand more traffic, right? 10 years before, we are satisfied with 1 MB per second. Right now, we need 20 Mbps per second, 100 Mbps per second, right? Or 15 years before, it was even downloading one MP3 file will take at least 30 minutes, 5 MB file. But right now, it's only less than 1 second it takes. So user demand is increasing as we move ahead, right? And that's not only the case. Our device per home also increase count, right? Having one mobile a decade before is itself a rare scenario, but currently in a household we are having at least 5 to 6 devices. Not only mobile right now, TV can, even the refrigerator connect to the internet. So at least 10 devices per in a smart home we are seeing. So increase in device also is led to development of 5G. Also, there are other technical stuff like low latency, high throughput, and those stuff which we will see how it helps with smart city. So that's the need. So it's end user need. We need more data to download or upload. That's why we need 5G. As well as the business compared to 4G, 5G has opportunity for a lot of business. So it's like an industrial revolution. It's going to change a lot of stuff in the industry, in everywhere. So that's going to be visible in another 2 to 3 years. We will see that. Okay, then maybe a couple more slides and we will jump onto the our topic, right? So I just want to show what is the difference between 4G and 5G. As I mentioned, latency. Latency means how faster your end server respond to your request. What is the fastest response time? In 4G, theoretically it's 10 millisecond, and in 5G you see less than 1 millisecond. This is theoretical value, but practically it's little bit different. But still, any case, 5G is 10 times faster than 4G. So we'll see how it is useful on our smart city applications. Okay. Also, the data traffic increase in download is also at least 5 to 6 times increase per month. Peak data rates for 4G can achieve 1 Gbps, but in 5G greater than 20 Gbps, even above that. We have carrier aggregation, other features, so we can achieve more than 20 Gbps as in 5G. And spectrum in 4G we can use at till 3 gigahertz, but in 5G you can go beyond 30 gigahertz. We'll see how this spectrum affects our throughput. We'll see that. And as I mentioned, connection density. Initially, we had less connections during 4G. Right now, the requirement to have at least 1 million connections per square kilometer. How we are going to, what are these connections? We will see that. Okay, next case. So, okay, these are real use cases. Okay, we have 3 use cases here mentioned. Extreme mobile broadband, massive machine communication, critical machine communication, right? So these are the major use cases for 5G. Whatever applications, whatever business model you use, it's going to utilize these 3 use cases of 5G. In our case, it's a smart home. I mean, smart city. Smart city needs all these 3 use cases for different applications. So extreme mobile broadband means more traffic, more throughput. As we discussed, greater than 10 Gbps. That will cover under extreme mobile broadband use case. Massive machine communication. Basically, in this massive machine communication means you don't need much throughput. You need less throughput, but your radio should cover thousands of devices. So it should cover mass number of devices, but throughput can be less. There is no reason for higher throughput, and also the battery performance, right? For example, you have wearable Apple iWatch, and that's a wearable IoT device, and that's one of classical example of massive machine communications, right? There will be a lot of devices in a particular area, and its battery capacity should be high, because when there is higher number of transactions between network and your device, automatically your battery will drain. So this network should be designed in a way that battery is preserved and the device can have at least 10 years of battery. That's the main concept for massive machine communication. Okay. And we have finally critical machine communication. In this case, latency is the key component. Latency is critical and you can't miss that target. So in this case, 5G, 4G can't achieve less than 1 millisecond, or Wi-Fi can't achieve that. That's why we need 5G. right? There are technical aspects behind it, right? That's technical how we are achieving this 1 millisecond, but we are not going to touch that. Our understanding is critical missing communication means less latency, and that's one of the use cases which we are going to use in smart city. Okay. Yeah, I will discuss about 5G latency, right? We'll see much more in later in examples, use case examples, right? So basically, latency is the key driver for critical missing communication, and that's the example how faster it can handle. But we have better example in our upcoming slides. Okay. Okay. Final slide in 5G basics. I also want to cover this. If you are working in communication or telecommunication domain, you're already aware of this, right? In frequency, right? In 5G, there are a lot of different frequencies. We call technically FR1, FR2. FR1 means low band and mid band, and FR2 is high band, millimeter wave. Okay, and if you see this one arrow, increase in frequency will always decrease the coverage. If you're going for a higher frequency, you're going to decrease your penetration or distance. So your radio tower can cover less distance if it is using higher frequency. But if you're using higher frequency, you're going to get higher throughput, much higher throughput. So that's why the low band will where you need maximum coverage but minimum throughput. And the mid band, average coverage, average throughput. And you see 2G, 3G, 4G, and 5G occupies both bands, but the higher band is only for 5G, where you will have less coverage but higher throughput. Basically, less coverage means you need to install more radio receivers, right? Small cells, you call it a small cell. So you need to have more radio towers across your city compared to LTE or 2G or 3G. Okay, but it's not going to be, we'll see that, but that's the main motto here. If you want to achieve a higher throughput, you're going to go for higher band. If you're going for a low throughput, but you need coverage, for example, massive machine communication, you don't need throughput, you just need coverage. You will go for mid band. So any operator, right? For example, in India, Vodafone or in India, it's going to be mid band, 3 gigahertz. It's going to fall under here. You will see average coverage with average throughput, but not exactly the higher throughput, which is yet to be discussed, right? India is going to be here. So it's different, right? Even if you have a 5G device, even if you connect to a 5G network, it doesn't mean you are going to get 20 Gbps. It depends on the frequency your operator is going to choose, right? In India, we will get around here, maybe 1 Gbps per second or 2 Gbps per second. That's expected, at least initial days. Okay. So that's the main message here is you increase your frequency, you decrease your distance. And each frequency has its own use cases, massive machine, critical, as well as extreme broadband. If you need higher throughput, you're going home users, right? You need higher throughput, you're going to use this. This is the pure 5G. Other or just like an overshadow of your 4G, but this is going to be a pure 5G. Okay, with this, we covered the introduction, why we need 5G, what is 5G, why we need 5G, okay, how it differs from 4G, what are the use cases, and how we are going to achieve higher throughput, how we are going to achieve higher coverage, right? Now we are moving on to the actual topic, the applications, how we are going to use this use cases, these 3 use cases, extreme mobile broadband, massive machine communication, critical machine communication in the smart city, right? That's where our next few slides is going to be. Okay, that's fine. Okay, before going there, we need to understand what is smart city, right? Maybe most of them know already, but I like to recap that. Basically, each body has its own definition. For example, here European Commission says that whenever you are trying to improve the traditional networks by using digital or telecommunication, which impacts or benefits your citizens and the business, it's called as a smart city. here in this case, traditional network means you have your traffic, right? Your traditional traffic, your traditional energy meters, your traditional home devices. If everything is getting connected via internet and it benefits the user and the business in a particular city, then that city can be called as a smart city. That's a theoretical explanation, but we will also see how it looks like practically, right? So smart cities needs to be basically has to have the supply, right? Basically, it has to have the bandwidth which can monitor lakhs of devices, gather data, provide some real-time response, and use the analytics to draw a pattern, right? So that it can be used to improve the product or improve the solution delivery or improve the life of our citizens or improve the business, right? That's the main goal for smart cities. It has to be more presentable to the citizens and the business, right? And it should bring in profit. It's not going to be the expense oriented. It's going to bring in profit based on the energy savings. We will see that how it looks like. Basically, there's one data point I am putting here. Like, so whatever I have is from internet or some articles, right? So you can always find these numbers everywhere in the internet, right? So if you want to refer, you can go ahead. So basically, by 2025, they're claiming that we will have around 75 billion devices which connects to internet, IoT devices. Basically, the total human population is 7.5 billion. But in this case, devices is going to be 75 billion. It means 10 devices per person it's going to be, right? So that's the target. That's the demand, right? To meet that demand, we need 5G. And a smart city needs 5G. That's the main motto behind this slide. So I have put here some examples of IoT, smoke detectors, connected waste page, electric meters, building automation. You will see a lot of stuff, right? Almost all this stuff are already available in Western or Eastern, right? Units, especially the South Korean, Japan, North America, right? They already have this. But in India, we have selected cities and selected, right? The trial still happening. It will take some time to reach India, but it's going to reach, right? It's always maybe 2025, 2024, we expect that. But this revolution is always going to happen in each and every country. It will take time, but it's always going to happen. So this is some examples, right, with this slide, and let's move on to. Okay, this is one thing. Okay, we know smart city. What are the interfaces, right? How it looks like. So we have three categories. We can divide all these use cases: human to human, human to machine, machine to machine. Human to human means basically, like example, this video conference, right? This is one of the example. Virtual meetings is a human to human. So that's one example. And wearables, you have your Apple device, you have social networking. Those are human to human. It's a social thing. Human to machine, it's going to be your internet connection, your video streaming, right? Healthcare, remote surgery. You will see that. What are the things, right? That's human. How your 5G is helping a human to communicate to a machine. And then finally, machine to machine, your surveillance, industry, whatever, right? Machine to machine communication is also road traffic, everything will come under machine to machine. Okay. Okay, next thing we started diving into exact components of smart city. For example, the first thing I want to cover is smart transport. Okay. Basically, this is going to be the attractive use case of a smart city. Right? This talks about the communication between your vehicle, for example, a car, communication between a car with to other car, right? Which is also has the smart transport, intelligent transport, communication between two vehicles, or communication between vehicle and the network, in this case 5G, and communication between your vehicle and infrastructure. We'll see the examples, right? So 5G is going to help to communication between two vehicles and it's also going to help communicate between a vehicle and the infrastructure. For example, a security camera, traffic lights, a road holes, right? Holes in the road. And it's also going to help communicate between vehicle and the network, right? Vehicle has to communicate between the network, it's going to use that. And in this case, we can also use 4G. Why we need 5G? We can use Wi-Fi. What are the disadvantages here? That's what we are going to see. Okay. This is one coordinated driving. This is one. So this is examples, right? What we talked about vehicle to vehicle communication. This is one example of that. Here in this case, for example, there is two cars, right? Imagine this is a highway, it's going straight, and you are just going to join from a lane, right? You need to jump into you need to join from a road to the highway. There should be some communication in automated or right. This is you need to share. This car needs to share. This vehicle needs to share the data that it is intended to join this highway, whether it can go or not. Right? Then what happens? So it will say, okay, for example, this originating vehicle will communicate. Okay, this is a group, right? Group of vehicles coming into that right area. It's going to communicate. Okay, I'm going to join this road at this point of time. Are you okay with that? And this either this car and this car will reply, okay, either okay or not okay. Right? And based on the response is going to take decisions. And what we are talking about is millisecond, right? This decision, this communication, message transfer should happen less than 1 millisecond, right? It can't take 10 millisecond or 100 millisecond. In this case, LTE or Wi-Fi can't be used. Wi-Fi is short range and LTE is higher latency. We need low latency capable radio interface which can communicate between the vehicles very faster. So there is no delay. This vehicle, okay, I'm going to attach to this highway. Are I'm okay to do that? Yes, and then it's go that. That's how it automated. It's going to use 5G is going to be used in the automated driving. This is the intention sharing. What is going to do? Am I going to suddenly stop? It's also going to tell, okay, this is going to suddenly stop. Halt, emergency stop, or those stuff, right? It's going to share that. We will see that. But that's one example how vehicles communicate each other, how 5G is helpful, not the other technologies. Another example, you see there is a roadblock or construction, whatever it is, it's going to intimate earlier to the automatic vehicle. Okay, there is roadblock, you have to take diversion. So your device is going to take diversion. In this case, reliability is more important. Does not be connection problem. There should be reliable connection. There should be video transfer. Okay, this is what's happening. I need to take this lane. Okay, so this is also one example of 5G used in intelligent transport. So basically, these are automated vehicles, right? It's already under trial and already almost available for commercial traffic, also available in Western countries as well as South Korea, right? Not in India. Yes, in other countries it's already in place. Okay. And another one of the sensor, right? When we are talking about IoT, you're talking about sensor, because here machine to machine communication, because sensor is the eyes and ears of a machine. In this case, a vehicle, right? Vehicle needs to know about its surroundings. How it's going to know? It needs to sense those information, infrastructure, right? So it's not useful to keep this sensing data within itself, right? It should communicate to other devices. For example, here in this vehicle, the vehicle 1 is sensing this vehicle. Okay, this is non-5G. I mean, it's not supporting that. It's not an automated vehicle, right? It's sensing that vehicle, these two vehicles, right? And even before this vehicle relays, right, it doesn't know this, it's not in the range, but it's already sensed that and already passed the message to this vehicle. Okay, there is already a non-autonomous vehicle in our path, right? Based on this information getting from the vehicle 1, this will react. right? It doesn't mean this sensory data is only useful for this vehicle. No, it's going to share across different vehicles, and other vehicles are going to make use of it. And everything happened within few milliseconds, and it needs higher throughput. It needs higher throughput and low latency. That's why 5G is required. It can't be achieved by LTE or Wi-Fi, whatever, right? It needs 5G. Okay, so it's going to happen in maybe real time soon. It's already there in India. It's going to happen real time. Okay, it's just how 5G works, right? So, for example, this intersection, all the vehicles are coming in, and the radio tower or 5G will consider this as a group, and these three vehicles will communicate each other. Okay, I'm going in, I'm going taking left, I'm going straight, right? And they communicate each other and take decisions based on that. And once they go out, right, and the group is dismantled, no more. So 5G should be in a position to create groups, create communication channels, and the destroyed group within few milliseconds. Group creation and the communication and the group deletion. And it's going to happen multiple times in a fraction of seconds, because you're going to see a lot of vehicles coming in. That's how the capability. I've just put here this slide to show how capable the 5G or any other technology should be, handle how much traffic, right? So its reliability should also be high, 99.999%. It should be on air. There should not be any downtime, because otherwise everything will be screwed up. If one radio tower is out of service, something else should take care of it, right? Otherwise, no point in going for this technology, right? That's the main intention for this slide. Okay, same thing here in 4G, right? Release 14 is your 4G. 4G also we tried this data, but what happened is, okay, this vehicle will communicate. Okay, I'm going to do right. I'm going to do the right turn, or I'm going to take this one. I'm going to stop immediately. It will just pass on the message. Nothing coming in. If you see there is no feedback, whether it's accepted, whether it's failed, message received or not, it doesn't know, because there is no response. But in 5G, you will also see NAC or ACK. ACK means acknowledgement. NAC means not acknowledgement. Okay, I don't acknowledge your data. Okay, either I didn't receive it properly, or whatever you sent is not applicable. I'm going to reject your command. So that one of the key highlights in 5G, because each message transaction takes your bandwidth. Higher the bandwidth, you can do this extra messaging stuffs, and we call it as ARC, hybrid automated repeat request. So that's ARC. It's a telecom term for retransmission. Okay, so that's one of the key on 5G. Okay, I think that's already covered. So that's the thing, right? The 5G transport, we gone through a lot of examples, and one thing what we know is it requires higher throughput, low latency, reliability should be high because there should not be any downtime. Your performance to high speed performance. So for example, your car might be traveling 100 or 200 kilometers per hour, and if it's a train, or it's going to be 500 kilometers per hour, then in that case also there should not be any packet drops. There should be high speed performance also. And application aware, right? There might be different applications being used by different vendors or different vehicles, but your underlying L1, I mean the physical layer, is always going to be your 5G. So 5G should have adaptability to based on your application, and backward compatibility. It should also support non-5G vehicles and other stuff, right? The backward compatibility should also be there. So this is the smart transport, right? These are the how 5G is going to help, and what are the key use cases being used by. Almost all use cases required for smart transport. You need low latency, you need higher throughput. So that's the key. Oh, this covers, this slide covers, okay, why you need 5G NR, you need low latency for reliability and those stuff, right? It's already covered. So yeah, that's fine. 5G, the 4G can't handle that. That's why we need 5G. And for transport, this is the success story I put here, right? That's a telecom operator called SK Telecom, right, in Seoul, right? And they worked with Metro, their government, right, the city, and try to implement this smart transport. For example, this is their use case, right? So for example, this car coming in and somehow without awareness, they are trying to cross the road. This car is sensing that information, and it's not only sensing that, it's passing message to nearby vehicles. Okay, there is a guy at this position, right? He is trying to cross the road. I'm going to stop, right, and take your own decisions. It's going to leave the decisions to the others, but it's going to pass the message to other vehicles. And second example is, you see in the right turn, there is a accident, and this driver manually won't know that unless they turn, they won't know that. But as a machine, this will land even before that. Okay, there is some stoppage, some accident here. Machine is going to learn that in autonomous driving, right? As well as the path hole. It's not, again, it's not going to learn, not just learn, it's going to pass message to other vehicles. Okay, there is accident. You need to take diversion or something like that. And the third example is path hole. If there is a big road safety problem, or there is a drain or whatever it is, it's going to sense again and pass the message to other vehicles. And this vehicle, when it reaches this position, it's already aware what is there. It's going to already alert the machine to take necessary actions. That's how intention sharing and sharing of sense data is going to help, and 5G is going to help that. Do it in real time, almost real time, on less than 1 millisecond. That's a theoretical. This is theoretical, and this is how they achieve, right? For example, this is the car, and they have antenna and those stuff. But since it's a initial stage, you will see these components outside, but it's not. Okay, this is one example. This is they already demoed this. And one data point here is, for example, here I put, right, if it's a LT network and your car is going beyond 100 kilometer per hour, and for some reason your autonomous vehicle decide to stop, right, based on the sensor, okay, there is some accident, I have to stop immediately, then your vehicle will take 2.8 meters to do that, decide, because it's going to take more than 10 milliseconds. So it will, your vehicle already traveled 2.3 meters already before taking a decision. But in a critical accident situation, near fatal situation, in 2.8 meters is still bad, right? You still end up with an accident, right? But what the 5G can do is, 5G can take decision within 28 centimeters, right? Your vehicle before reaching 30 centimeters, it already will take the decision to stop or take a turn or whatever, right? So that's the difference. It's almost like 5G can turn a fatal accident into a life-saving feature. That's why 4G is not recommended for autonomous driving. You need 5G, and how the latency and reliability needs to be there. That's one of the success story for SK Telecom. And this one example I have put here, a lot of other telecom operators doing demo with their government so that they can grow their business, right? Now telecom is saturated. We are paying around 300 rupees for a 3 months of data. That's very less compared to what they already put the capital, right? And we can't expect telecom operators to again invest in additional hardware for 5G. They're not going to do that unless they have a revenue from that. That's how they're doing. So network operator demoing this, and they will sell this product to the government, to the other private businesses, so that they can increase that portfolio. That's the main aim for 5G. It's not only end user, it's also for business. Okay. With that, smart transport is done. Okay. Let's move on to the smart healthcare. So whatever we did in smart transport is all use cases are almost similar, but applications, how they utilize, it's going to be different. For example, smart healthcare. One example is we already in Corona COVID situation, we already have video conference for a physician or doctor, right? We already consulting with them, but that's a very basic smart healthcare, right? You don't do much. You just communicate with them. They help you. Okay, this is your result. They will read the result. They will provide you some suggestion, consultation, but nothing else, right? That's the first stage of healthcare. But there are a lot of other use cases which can utilize 5G, right? For example, imagine there was an accident and there was some ambulance, right, carrying the patient, and he needs immediate surgery or immediate recovery, whatever, right? And not ambulance doesn't have a surgeon, it don't have a surgeon, but a surgeon can do a remote surgery or remote diagnostic from wherever he is located. It doesn't need to be present in an ambulance or a place where the problem happened, right? It doesn't need to be there. He can be in remote area. He can give his guidance or even do the remote surgery, right? And that's a key thing. That's one of the use cases for healthcare. And other stuff for, you have the smart wearables where you can wear the watch and it will monitor your heartbeats, BP, and those stuff, and it will send the data to your doctor or your hospital, and then it will collect the data, and whenever there's a rapid change or any suggestion, it will definitely give you the suggestion. Okay, this is what's happening, and this is the data what we get, and this is what you're going to do. So that's one of the use case for the healthcare. We'll see one by one, right? Live examples, how it looks like and those stuff, right? And telemedicine, this is what I talked about. Telemedicine is just a video conference you're doing with your consultation, which is already there. You're already doing it. We're already doing it. But imagine, what if we are right now we are doing this video call, and even if everyone is turning on their video cam on, right, video camera, you even if you don't have a bandwidth, for example, if it's a LTE, then it's not going to support it, right? It can't support video streaming from all the devices because it doesn't have enough bandwidth. But 5G can do that because 5G has enough bandwidth. It uses a higher frequency, right? Same thing you can apply. For example, there is a doctor. You need to consult a foreign doctor who knows only English, but you don't know English, and you need a translator in between that. So translator will also join your video conference, and he is also going to share the video. Then there's a increase in demand. You need more throughputs to cover that. So that's one example. What the bottom line is, we are using telemedicine currently at the basic, but 5G is going to improve that with more additional features. That's telemedicine for you. Okay. Remote patient monitoring, same thing. You're going to wear something like a watch, and it's going to increase. Currently, the users are less, but in Western and Eastern, the users are demanding. I think we are expecting in India also it's going to increase because, yeah. So increase in number of device, this kind of device, IoT devices requires an increase in capacity. That's why we need 5G, as well as 5G is going to help in reducing the battery, right? Even the battery consumption is going to reduce by using the advanced air interface messaging. It's going to reduce even the battery consumption, right? And so that it's going to develop a new business portfolio for healthcare organizations. We will see that how it's going to, there is remote patient monitoring and those stuff, how it's going to help, right? And augmented and virtual reality. I think most of them knows what is augmented and virtual reality. I have better example later, but how it's going to be used in healthcare. For example, right, in AT&T in US, they already gave a demo. For example, there is a cancer surgery happening, right? And then around 55,000 students, the medicine students, they watch the live surgery using this augmented and virtual reality. It's like You put this wearable and you will see like a 360-degree of your surgery table and those stuff, right? You will feel like you are present during the surgery. And it's like, if you can support 55,000 devices streaming, then it's going to do a lot of changes in education as well as your medicine, not only in healthcare, it's going to also engineering also is going to, everything is going to change, right? You no need a 2D paper printout anymore. You already have a 3D in hand, right? If you're going to give a demo, you're going to give everything on 3D, and you don't need to be present in a closed environment. You can be in remote area to study. That's the main motto behind this augmented virtual reality, right? Studying your operations, your surgery, and those stuff in healthcare. And 5G is going to help that. And finally, data analysis. Data analysis is going to be key part in automation everywhere. Not only medicine, healthcare is going to be on education, engineering, telecom, wherever you go, right? Data collection and using the collected data, analysis and preventive measures, right? Predictive analytic, preventive measure are key concept for continuous development. For example, if, for example, there is a diagnostic, and for a diagnostic there is a recovery method, and your cloud computing and those stuff can post process the data and give you a predictive on like, oh, this is what's going to happen, and this is going to reduce your time in diagnostic and those stuff, right? So it's going to analyze the data and provide you a better method or better way of working. That's the key. Data analytics is very generic. It's applicable for all industries. Okay. And this is the key here. This is one of the best use. This is the business portfolio, right? For example, nowadays, hospital is a one centralized location. You visit, you can be either inpatient, outpatient, but you have to physically present there. And that doctors will also be physically present. But in future, with use 5G, you can do something like this: walk-in clinics. There might be some clinics every nook and corner. You just walk in, do your blood test. You don't need a doctor. You don't need assistant. You don't need a nurse. You just do your own blood test, everything, and robot will collect the data. It will pass on the message. So basically, that's a walk-in clinic. And urgent care centers, right? For example, there's a care center, but you don't have all specialists there, and you need some critical surgery immediately, and you can't wait for a doctor to arrive. In that case, you have a remote surgery. A robot can do the surgery, and a doctor who present in thousands of kilometers away can handle that robot with precision, with very minute precision. For that, you need very less latency, and that's what 5G is going to do. And if you see, if it's very successful, then you are going to there is going to be vast change in portfolio of your healthcare. Not immediately, not in 1 or 2 years, but in maybe in a decade. In 10 years, you will see this kind of walk-in clinics. Right, everything is going to get automated. Wherever possible, automation plus your 5G is going to dominate. Okay. And this is one success story I put here. Right. For example, in China, they already did a remote surgery on a human brain. Right. And this is the surgery table, and this is the robot. Right. And you see, the doctor were located 3,000 kilometers away. The specialist, and he did human brain surgery using this robot. He controlled this robot similar to the hand, right? Manual operating. He did that surgery, and you see the students, they're learning from that. So how many use cases in a single application here? You see the remote surgery, which required less latency, and you see students learning from video that needs higher throughput because it's going to be 4K streaming, not 2K anymore. It's going to be 4K streaming. It needs higher bandwidth. So this is one of the successful story in China. They did that. Okay, so that's how it might look complex. Okay, it might look not safety, but imagine this, right? It's more safe than human. Human can do a manual mistakes due to aging, stress, and other environmental factors, but your robot is not going to do that, right? It's going to be 99.999% reliability. That's what it's going to achieve. That's what 5G and other industrial automation 4.0 is going to do that. Okay. With that, I think I have maybe 30 more minutes. I will try to cover smart grid, right? So this, because smart city, right? We already covered transport, healthcare. Next thing is energy management. That's one of the key use cases, right? In a well-developed city, will take input electric from different sources, right? It can be renewable sources like coal. It can be from nuclear. It can be from hydro, wind, right? Everything will be merged, right? There should be load balancing. There should be energy distribution, energy metering, right? And you can't have cables running around for each and every household, right? You can't run cables for every other substation. No, you don't need cables. You just have 5G. All IoT devices, all energy meters, everything, water meters, everything is interconnected, right? You don't need to take reading. You don't need to visit each and every household to take readings anymore. Everything is automated. Every data is feeding into your thing. That's not the only advantage of 5G, right? It's not only taking the reading. It's also going to help you save energy, right? It's going to monitor the critical parameters of your substation, and it's going to alert. It's also going to load balance, and also it's going to improve the security. It's going to avoid overload. It's going to do a lot of stuff. It's not only taking energy meter, right? This is one example. Nokia, right? In telecom, the 5G leaders are Nokia, Ericsson, Samsung, Huawei. These four are the top leaders. They are the product producers, right? And then there are operators. So in this case, Nokia, who is a telecom supplier, worked with ABB. ABB is one of the electrical company, global electrical company, and they showcase the this demo, right? How wind farm, solar, and other sources data is coming in, and you have the centralized data center which process the data based on the load, right? For example, if there is a higher load in a particular source, it's going to redirect your supply, energy supply, and those stuff, right? To your intelligent buildings and for your EV cars and your smart homes, right? Smart homes, you have energy meter, smart energy meter, so everything interconnected. With 5G, no cables running around. There's not underground cable, nothing, not required. You just need a 5G for that. That's one of the use cases for smart grid. So we have transport, we have transport, we have power grid, we also have, right? So we already covered 3 use cases. And the next thing is video surveillance and analytics. So this is one of the key important, right? Security. A city is not smart if it doesn't provide enough security, right? So the first use case is, imagine you have CCTV, you're capturing everything, you are streaming in, there's a security who is monitoring the CCTV monitor, and if it's a LTE, it's going to stream 2K data, 2 or 180p resolution. You always see in YouTube, there is a security footage, it always pixeled, right? You won't see a face clearly. You won't see the license plate clearly. And then that's no use of CCTV. You need to stream at least 4K video, or in this case, 5G can also do 8K, right? CCTV. And you're talking about thousands, lakhs of CCTV in an entire city, all right? And if 5G can handle those data. It can stream 4K and 8K. So the security personnel who is checking the video on the other end can clearly view the face or the car license plate or whatever data he needs. There is no pixel, right? That's one of the key. And that's not the only. CCTV is not going to be the only security or video surveillance method. And video surveillance is not the only use case. There's also going to be analytics, image processing, comparing two images to understand, okay, what is there? We'll see that. I have use cases for how image processing, digital image processing, how image processing can be used for security reasons. Okay. And this is a success story, right? This is one of the Hong Kong, right? In Hong Kong, this is one of the robot which communicates with 5G. What it does is it's in an airport, and during they call it as Captain C, right? And it was established during Corona. What it will do is it will check the temperature, also check if human is wearing the mask, right? If they are not wearing the mask, it's going to take the photo and it's going to send immediately to the security person, right? So this one of the video surveillance is going to do. It's already doing it. I mean, it has 360-degree camera. It can zoom around. It will move around the airport. It will check a random person for the temperature as well as mask, right? It will check the mask, and if no one is wearing that, it's going to highlight or alert the security, and they're going to take. So that's one of the key, one of the example of video surveillance and analytics, right? Because analytics is image processing is required to understand if a person is wearing mask or not. So everything will happen in few milliseconds. That's why you need 5G, right? And coverage is, for example, if you're going for a Wi-Fi is maximum 30 meters. You need to set routers everywhere again, and it's not reliable. It's a high latency. So that's why you need 5G. Even 5G is going to replace in-home Wi-Fi in future. Right now, everyone is Wi-Fi router. We are going to have 5G routers in future instead of Wi-Fi. And I also put one more use case, right? This is also an airport. This robot is called as a spot. What it will do is it will just move around the fencing, right, of the airport. More on the fencing of the airport. It will take images, videos, and do the analytics. Okay. It will check the fence. If there is any damage, if there is any break-in evidence, it will, how it will have, no, it will, based on the image processing, right? It will do that, and it will, and again, Wi-Fi can be established everywhere. That's why you need 5G, right? 5G has higher penetration, and when they used Wi-Fi for this robot initially, and they had limited coverage, and they moved on to the 5G. Now this robot can roam anywhere in the airport, check for break-ins and those stuff, and alert the security person. This is again one use case, video surveillance, where Wi-Fi has disadvantages and 5G help and achieve that. And it's going to have deep learning methods, as mentioned here. Perimeters, it will check the fences if there is any signs of damage. Right? It will avoid human. Otherwise, human has to check, go around every time and check it. No, that's not required. Right? So now it's going to take care by the robot. With that, we already covered 4 use cases. I think I have 15 more minutes. I will try to cover rest of the stuff. Okay. Immersive experience. This is also part of city, right? This is one of the cosmetics, and where basically whenever there's a virtual reality, augmented reality, we always talk about gaming, right? It's not only about gaming, as I mentioned before. It's also used for healthcare, education, as well as sports, even events. How it's going to be used on events, we will see that. But we need to know difference between 360-degree live experience. Imagine right now we are watching a cricket or football World Cup from our home. Not everyone gets the opportunity to visit the ground, right, or the play field. We are here we are tuning into our television and we are watching the match. Imagine in future, not in future, it's already demoed and working, but I'm talking about availability for all the consumers. Okay, so imagine in future you will wear a glass which will make you feel like you're already in a stadium. It's a 360-degree. When you turn to your right, you will see some viewers. You will see, you will feel like you are sitting in a stadium. You're watching the cricket or FIFA match live. You will see you will hear the audio. You will see the video similar to what you are in the stadium. That's a 360-degree live experience. Similar to virtual reality. Virtual reality is almost looks like a 3D view. For example, in gaming, right? It's like it's immersing yourself into the game. Augmented reality. Augmented reality is like a layer above your video. I will show what is the difference, right? In your car or in your repair in the industry or in your mobile, you will see something on top of the video or on top of a sports event. That's augmented reality. We'll see that in use cases, right? So this is also should be part of smart city. Smart city should not always talks about safety, transport, and those. It also talk about experience. It also talk about your cosmetic experience like this. It's not optional, but still required. This is the first use case, and this use case for virtual reality. Okay, and you see there is a screen where the game, right? There's a game, and this guy wears a glass, and in the leg also there is some sensor, right? And if he tries to kick, and it will also be, this is a virtual reality. You will feel like you are already in the football field and you're kicking the ball, right? But actually so the communication between the processing unit of this game and this sensor is 5G communication between that, right? Because the latency is less in this case. You need a very good latency in an online gaming platform. That's why you need 5G. Okay. And another use case for augmented reality. This is what, right? On top of already existing. For example, in this case, in the store, they're opening the camera and it's showing where you have to pick which product. It's going to give you where the product it is and what is the distance and those stuff. It's augmented reality, right? Store owners, or they have to already process the data, image processing, and give this data. So you open your app in your mobile and your camera, and it's going to show where you're going to pick it. This is one use case for augmented reality, and it needs higher throughput, reliability, and those stuff where 5G can do that. And this is one example of repair, right? For example, if for example you are configuring or connecting your home theater and you don't know how to do that, and your manufacturer giving you instruction on augmented reality. Okay, show your phone camera, show your sound bar, and it will show which cable needs to be connected where, right? Your app will recognize that model, and it's going to recognize each port, and it's going to give you instructions based on that. That's augmented reality for repair. It can be used in industrial or consumer products. It's already there. That's one example. And bottom is sports event. You see, when you're going to you open your mobile, and it will show statistic for each player, and it can also merchandise. It will, but you can purchase the merchandise and those stuff. It's going to be a business thing. In the right, you will see the augmented reality. In a glass, you will see this wherever it's either it's regular gas or it's something, you're going to see this statistic and your game. You can have your entire game in your tabletop. That's augmented reality. It's something layer on top of your video. That's the augmented reality. These are the use cases. Everywhere you need higher throughput. It's going to be 4K or 8K streaming. You need 5G data here. 4G can't handle this traffic. Finally, smart building. This is going to be my final use case, right? I think I'm on time. Smart building. It can be home or office. City is not going to be smart if the end user consumer home is not smart. Our home should be smart for a smart city, right? For that, it's going to sense. I put some examples here, but there are a lot of other examples. How many occupants are in the building? Either someone stranger, someone is already there, someone, right, who's not supposed to be there is there. It's going to sense that. What are we talking about is sensors, right? Everything is sensor and data processing analytics, right? And where 5G is going to be the component which is going to help, but again, it's going to be sensor IoT devices, occupancy sensing, air quality monitoring, leak detection. For example, if there's a gas or any leak, it should be immediately informed, alerted. That's why the 5G is going to be there. Leak detection, facility, environmental monitoring, your temperature, your waste management, parking, everything is going to be, that's IoT devices interconnected. If you, then we call it as a smart building. A building which can process all this data and help users to achieve a better life, then it's going to be a smart building, right? And this example here, you can control your AC temperature, you can do the smart TV, security, ring road doorbell, smart lamps, camera, outlets, power outlets. But we can say that it's already there, right? You see, you have Amazon Alexa, you have Bluetooth control speaker, you have Wi-Fi control air conditioning. Why we need 5G? Because Bluetooth is going, it's not, if you have Bluetooth speaker, but you don't have Bluetooth AC. I'm just giving an example, because AC is going to work on Wi-Fi, the camera is going to work on Wi-Fi, your smart TV is going to work on Bluetooth. Then you have each device it's going to use on different technologies to communicate. Right now, our camera can't communicate to the smart TV. Our smart TV can't communicate to your AC or whatever, right? Devices don't interact with each other. We have mobile which interact with some certain components, but in future, 5G is going to be a common interface for all things, TV, AC. So you have control center, a mobile, which can control everything via 5G. You don't need to turn on Bluetooth, you don't need to turn on Wi-Fi, you have everything for 5G. That's the main motto behind. And for example, the leak detection, it should be very minute, very reliable. Since sensory data can't fail, should not fail. That's why you need 5G. Okay, with that, I think those were the use cases. So what we discussed so far, right? We covered, I think I'm just going back to the old slide. So we covered smart transport, healthcare, electricity grid, video surveillance analytics, immersive experience, smart building. I gave you some basics as well as some how the world is evolving. What are the success story, right? That's going to be very useful to. So when you have an idea and then you map it to a success story, then you have a picture, pretty good picture. What does it mean? So basically, smart city doesn't mean you have internet connection everywhere. It doesn't mean that. Right now in India, we have a different way for a smart connection, right? Whenever there is an internet connection, it means smart city. It doesn't mean that. What doesn't mean is just internet connection. You need to have intelligent transport, healthcare, grid, everything should be there to have a successful smart city. All right, that's what I tried to project in our presentation. And finally, my conclusion is, let me go to my conclusion slide. Right. So 5G is going to be everywhere, not now, right? Now countries like our countries and some Asian countries is not yet started 5G, but soon it's going to be arrive. High bandwidth, low latency, and better energy efficiency is going to be the key drivers for 5G. And transportation, citizen services is going to be the key drivers for smart city, right? And mobile operators is going to push this idea towards the government so that they can get revenue out of 5G, right? They are going to deploy lakhs of antennas, lakhs of radio towers across the nation. That's a capital, right? They have to gain something from that. It's not going to be a user, end user. Broadband is not only going to give that. They're going to telecom operators now jumping into different domains. They are jumping into, for example, Qualcomm is jumping into transport, automation, intelligent transport. They are jumping into healthcare, and even Qualcomm is jumping into telecom. So Nokia now as a telecom supplier, they are also jumping into healthcare. They are jumping into robotics, industrial automation. So it's not going to be one supplier. It's going to be one supplier because it's always going to be a software. The software as a service. Everything is going to be a cloud. Software is just the software is going to change. So software either Nokia can provide, Qualcomm can provide, anyone can provide. You just need IoT devices plus cloud server, right? So that's a business motto. And now what we are talking about is 5G. But 5G is already there for 3 or 4 years in US and now South Korea. Now they are already talking about 6G. So 5G is already the higher throughput latency, even what 6G is going to cover, right? It's going to, they call it extreme low latency. Even less than 5G, reliability and key is, there's some other feature, device to device communication, and those even your phone can communicate to other phone directly, right? Data transfer, and even greater than 100 Gbps. So what I'm mentioning is 5G is there. 5G is going to be implemented in another 10 years, but it's not the end for telecom. 5G is not going to be the end. So as a human, we are not going to get enough data anytime soon. So we will demand more, and operators are already researching for 6G. That's where we are. So that's my conclusion. 5G is going to be a key role in smart cities, and because Wi-Fi and 4G can't supply the necessary demand, and even 5G is not enough for something which 6G can provide. That's my conclusion. And with this, I'm closing my session. Okay, if any concerns, questions, please do rise. I will try my best to help you get answers. Okay, back to you, Yuvraj or Karthikeyan, who are hosting this call, please. Hello. Guys, are you there? Raja, Karthikeyan, you might be talking on mute. Sorry.
Yes, sir. Audible, sir.
Yeah, so that's my conclusion. So I concluded my, I think it's already 3:45. I think I concluded my session, and I think I am ready for if there is any questions. I can take questions. If not, we can wind up.
Yes, sir. Participants, if you have any queries, do put it in the chat box or do raise your hand. Participants, if you have any queries, do put it in the chat box or just raise your hand so that we can unmute you. No questions are there, I think so, sir.
Okay, that's well and good. So thanks everyone for listening into my session. I think I'm happy to deliver it. Then Yuvraj, I think back to you, Karthikeyan. I think we are done for the day, right? Let me know if something else required.
Yes, sir. We can conclude the session, sir.
Thank you. Thanks.
When educating the minds of our youth, we must not forget to educate their heart. In this way, I'd like to propose the thanks to our today's resource person, Mr. Arun Kumar, for delivering a wonderful technical speech. Thank you very much, sir.
Thank you. Thanks for that.
Thank you, sir. And I also like to thank all the participants who have helped us to complete this day too. Thank you, everyone. And the attendance and feedback link is provided in the chat box. Do fill it out within 30 minutes. Participants who haven't filled the attendance from feedback form provided in the chat box, do fill it out within 30 minutes. And the day 3 session will exactly be started at 10 tomorrow. Thank you.